Welcome. In this video, we shall be looking at geothermal energy. Learning outcome. In this video, you will understand geothermal energy, origin of geothermal energy, extraction of geothermal energy, operation of geothermal power plant, advantages of geothermal energy, and disadvantages of geothermal energy. Geothermal is a two-word meaning geo and thermal. Geo stands for earth, while thermal stands for energy. So geothermal energy is the heat energy that is generated and stored in the earth crust. It is a type of renewable energy that is obtained from the heat stored inside the earth. It is a clean and renewable energy. It is a sustainable source of energy as it does not require the combustion of fossil fuel and generate low greenhouse gas emission. So this energy can be used directly in the form of heat or converted into electricity using geothermal power plant. Let's look at sources or origin of geothermal energy. There are two main sources of geothermal energy. One is decay of radioactive element. The second one is residual heat from earth formation. Let's look at each of them. Decay of radioactive element. Nuclear decay processes of radioactive elements such as uranium, plutonium, or thorium in the earth mantle generate constant amount of heat over millions of years. So it's one of the source. Another one is residual heat from earth formation. Geological processes that occur in the original formation of planet about 4.5 billion years ago generate heat, and this heat is trapped in the planet's inner core, particularly the core and the mantle. As we can see here, as we can see in this picture, this is a cross-section of planet Earth from the inner core, which contains molten magma. The temperature here is about 4,000 degrees Celsius at the depth of 6,370 kilometers. So heat is trapped within, and this heat is from the formation of the Earth crust. And like we earlier mentioned, also radioactive decay activities generate heat, which is stored in the mantle as well. So all this heat is what we use in geothermal energy. Extraction of geothermal energy. We have established that geothermal energy is the heat trapped within the earth crust, which could be due to radioactive decay that generates large amount of heat that is trapped within, and also heat trapped in the inner core of the earth from formation of the planet. Let's look at how we extract this energy. One of the way that we obtain this heat is by drilling well underground to access the earth internal heat. Is one of the way. And the other one, depending on the temperature and depth of the resources, there are different methods of exploitation. To obtain geothermal heat from within the earth interior, earth internal, we have to drill a well underground so that we'll be able to access the heat. And depending on the temperature and the depth of the heat, there are different methods that we use to exploit this heat energy, this geothermal energy. Okay, these are the processes. The first one is dry steam system. Here we extract the heat in the form of steam. The steam here is produced when the heat in the interior heat up the water in the water table, and from here steam is produced, and this steam can be channeled directly to a turbine. which is used to turn a generator. And in the process, electricity is being generated. The other one is through the use of hot water or geothermal fluid system. Here, the hot water and the steam is channeled through a separator. The separator separates the steam and is channeled to the turbine to drive it, while the excess water is channeled to the reservoir to maintain the aquifer in the reservoir. Then the third method is heating and air conditioning. And here, heat from the interior is extracted into a building using a heat pump. And during winter, the heat is used to heat up the building, while during summer, the heat in the building is extracted. So through this, there is the heat in the home is being maintained. So the dry steam system, let's look at it proper. Here, steam is extracted from the underground, and the steam is channeled directly to a turbine to generate electricity. Then the hot water or geothermal fluid system. In this case, hot water is extracted in form of steam and water from the underground, and this is passed through a separator that separates the steam from the liquid, and the steam drives a turbine, and the excess water can be reinjected into the reservoir to maintain the sustainability of the resources. This is the second method that we use in the extraction of geothermal energy. And then the third one, like I earlier explained, is heating and air conditioning system. Here, heat is being extracted using a heat pump. As we can see here, the heat pump is used to extract heat, and a copper pipe is buried on the ground to extract the heat, and the heat is channeled into the heat point. During building, is used to warm the house, the building, while during summer, the heat is extracted back from the building into the underground. So through this process, heat is maintained in the building. So these are the three main methods that we use in the extraction of geothermal energy. Okay, let's look at geothermal energy generation. How do you use geothermal energy to generate electricity? Geothermal energy generation is a process that allows us to harness the heat contained within the earth to produce electricity and provide heating and cooling efficiency and sustainably. Heat pump and geothermal power plant are employed in geothermal energy generation. Let's look at how it is done. Operation of geothermal power plant. Geothermal power plant convert heat from the earth interior through the use of a thermodynamic cycle. And in the thermodynamic cycle, the first process is heat extraction. And here, geothermal wells are drilled to extract hot water or steam from within the earth interior. Then, this heat is converted into mechanical energy, and the steam is used to drive a turbine connected to electric generator. That is, the turbine transforms the kinetic energy of the steam into mechanical energy. It's the second process in the operation. Then the next one is electricity production. The mechanical energy is transformed into electricity, which is injected into the electric grid and is used to power homes, industry, and a wide range of consumers. And then the fourth process is water recirculation. Once used, the cold water is reinjected into the subsoil to maintain the balance of the aquifer. So these are the operation of geothermal power plant. First of all, these are the process involved in the operation of a geothermal power plant. A well is drilled into the interior to extract the heat. The mechanical energy of the steam is being converted, and from there to turn the turbine. From there, electricity is being produced, and the cool water is recirculated to maintain the aquifer. So these are the processes involved in the operation of a geothermal power plant. So, like we earlier explained, this is a dry steam power plant. Like we said, a well is dug and into the interior, this is a rock layer, and from here, steam is being extracted to drive the turbine. This is a turbine, and in the process, the turbine is used to turn the generator, and electricity is being produced. As we can see, this dry steam power plant. Then the second one, like we earlier say, hot water or geothermal fluid system. This is the example. Here, a well is dug to extract the steam. We have the steam here coming up. The steam and water reaching a separator is used. The steam is being separated and is channeled to the turbine to turn it. And in the process, connected to a generator, electricity is produced and is being distributed, while the water will be channeled to a condenser and is re-injected into the subsurface to maintain the aquifer. So this is another process in the operation of geothermal power plant. Okay, let's look at the advantages of geothermal energy. One of the advantages is high efficiency. Minimal thermal energy is lost during the process, and this makes it the most efficient renewable sources of energy. Another one, constant production. Geothermal energy is stable year-round due to high thermal inertia and insulation. Like we say, the heat is trapped within the earth interior. So minimal heat is lost, unlike other sources of energy. So another advantage is that geothermal energy exists everywhere. So geothermal energy is found globally, unlike deposit-dependent sources like fossil fuel and even solar energy. It's not everywhere that you can use solar energy, even fossil fuel. It depends on where you have the deposit. But in the case of geothermal energy, it exists globally. Another advantage is that it does not depend on the weather condition. So geothermal energy is unaffected by weather variation, unlike solar that depend on the atmospheric condition. If the weather is cloudy, there will be no sun, and because of that, one cannot use solar energy. Also, like a hydropower, if there is no rain, there will be no water in the dam, and as a result of that, one cannot use it. So geothermal energy is not affected by weather. Also, it is useful in summer and winter. Like we earlier explained, we use heat pump to provide heat during winter, and during summer, the house is cool using the heat pump. Heat is extracted from the building. So these are some of the advantages of geothermal energy. Other advantages include it is viable for private individual. In an individual, it is suitable for isolated home and requires simple maintenance is another advantages. It is a renewable source of energy because it's environmentally friendly and it is inexhaustible. Minimal waste is generated. It reduces environmental impact compared to other sources, does not pollute the environment. Also, economic saving, this is another advantage. Low consumption and high performance lead to cost reduction. It is very, very economical. Then minimal visual impairment. Since the installation is done underground, it requires minimal visual impairment, unlike wind farm and solar farm where a large portion of land is required. Here, the effect is minimal. So these are some of the advantages of geothermal energy. Anything that has advantages also has disadvantages. Let's look at it. Unviable in large city. Geothermal energy required subsoil, it occupies subsoil, and in large city there are no empty land where one can use to construct a geothermal power plant. So this is one of the disadvantages because of the land required. One may not have a large portion of land in the city for construction of geothermal power plant. So another disadvantage is location restricted. It requires specific geological characteristics. It's not everywhere that one can install geothermal power plant. Places like swampy area is not a good place for installation of geothermal power plant. Also, high initial cost. It is very expensive to install geothermal power plant. Another disadvantage is only local exploitation. Here we are talking about heat. Heat cannot be transported as primary source. So geothermal energy is mostly exploited in the locality where it is being produced because of the heat that is being extracted from the location. Environmental impact. Landscape deterioration from drilling. Before we can extract this heat, we have to drill. So during the drilling, it affects the landscape. Then possible toxic emission is another disadvantage. During the drilling, there is risk of release of harmful substances which may affect the inhabitant, and it has several disadvantages of possible toxic emission during the drilling. So these are some of the disadvantages of geothermal power plants. Let's look at geothermal energy plant in operation.
You may have relaxed in a natural hot springs pool, or seen the old faithful geyser blasting hot water into the air in Yellowstone National Park. But have you ever thought of where all that heat comes from? Well, it comes from deep beneath the surface of the Earth, and it's called geothermal energy. And we can use it to generate clean, renewable electricity. Okay, here's how geothermal works. Heat from the Earth's crust warms water that is seeped into underground reservoirs. In some places, when water becomes hot enough, it can break through the Earth's surface as steam or hot water. This usually happens where the Earth's crust, or plates, meet and shift. In the past, taking advantage of geothermal energy was limited to areas where hot water flowed near the surface. But as geothermal technologies advance, we can leverage even more of these natural, renewable energy sources. Engineers have developed a few different ways to produce power from geothermal wells drilled into the ground. Have a look at this. It's a dry steam geothermal power plant, and it's the most common type of geothermal technology used today. Underground steam flows directly to a turbine to drive a generator that produces electricity. Pretty straightforward. Another geothermal technology is called a flash steam power plant. A pump pushes hot fluid into a tank at the surface, where it cools. As it cools, the fluid flashes, or quickly turns into vapor. The vapor then drives a turbine and powers a generator. A binary cycle plant works differently. It uses two types of fluid. Hot fluid from underground heats a second fluid, called a heat transfer fluid, in a giant heat exchanger. The second fluid has a much lower boiling point than the first fluid, and so it flashes into vapor at a lower temperature. When the second fluid flashes, it spins a turbine that drives a generator. The environmental benefits of this clean, round-the-clock, renewable energy source are substantial. Low emissions, small physical footprint, and minimal environmental impact. The few byproducts that can come up are often re-injected underground. Geothermal energy can also help recycle wastewater. In California, wastewater from the city of Santa Rosa is injected into the ground to generate more geothermal energy. Some plants do produce solid waste, but that solid waste may contain minerals that we can remove and sell, which lowers the cost of this energy source. The U.S. Geological Survey estimates that untapped geothermal resources in the United States, if developed, could supply the equivalent of 10% of today's energy needs and cut our dependence on fossil fuels. In fact, Electricity generated by geothermal energy already provides about 60% of the power along the Northern California coast, from the Golden Gate Bridge to the Oregon state line. Geothermal energy, helping to push America toward energy independence and a clean, renewable way to meet our growing energy demands.